So in the last videos, we have seen how the properties of a substance changes during the phase change. That means first solid to saturated solid, and then to saturated liquid, and then to saturated liquid, and then to saturated vapor, then to superheated vapor. So we have discussed about the change in properties like pressure and specific volume during this phase change. Now we will try to show the change in properties of temperature and entropy during this phase change. So that is represented in a TS diagram. So in the y-axis you have temperature, and in the x-axis you have the entropy. Okay. So before proceeding with this diagram, we need to know one important relationship. That is, we have seen that the heat supplied is equal to Cp into T, and Q is equal to TdS for a reversible process. So this is equal to Cp into dt. That means ds is equal to Cp into dt by T. So that means if you integrate between the limits 1 and 2, S2 minus S1 is equal to Cp into log T2 by T1. So this is the relationship connecting entropy with the temperature. That means as temperature increases from this relationship, you can see that the entropy also increases. Okay. Now, so let us start with the first state, that is 1, that is solid. 2, that is when it is heated to, it becomes the saturated solid. That means it is about to change the phase. So it will be like this. It is from 1 to 2. Okay. From 2 to 3, that is from saturated solid to liquid. That means it is changing the phase, it is melting. So this will be from 2 to 3. Okay. So during this process, okay, 2 to 3, since it is a phase change process, you know that for a phase change process, temperature is constant. And when the solid is heated, you can see that its temperature is increasing. That means if you take ice, for example, if it is heated from minus 25 degrees Celsius to 0 degrees Celsius, temperature increases. So this entropy also increases. Right. But during the phase change process, if you take ice, it is 0 degrees Celsius to 0 degrees Celsius water. So temperature will not change, but entropy will change. Okay. Because here Q is the latent heat. During the phase change process, you are supplying the latent heat L. So Q is equal to TdS, that is L. So ds is equal to L by T. So that means it is so for a constant temperature, entropy increases. That is S2 minus S1 is equal to L by T. Okay, temperature is constant. So that is why it is shown as 2 to 3. Now if you again if you heat, now it has become a saturated liquid. So again, if you supply heat, you can see that its temperature rises and also entropy increases along with this temperature. Now it will become saturated liquid, that is it is about to become vapor. Okay, so it is state 4. Now you can see that from 4 to 5, right, there is a big increase in entropy. From 4 means it is changing from 4 to 5, it is from liquid to vapor. So there is a huge increase in entropy when the substance changes from the liquid state to vapor state. So it is from 4 to 5, there is a big gap here. And again now it has become the saturated vapor. If it is heated further, its temperature increases and entropy also increases. Now it will become 5 to 6. Okay, so this is how you show a constant pressure heating. So this is a constant. So here throughout the pressure is constant. You need to keep that in mind. We are using a constant pressure heating. Okay, so you will get 1 2 2 2 3 3 to 4 4 to 5 5 to 6, like that, right? Now if you are repeating this experiment, if you are repeating this heating experiment at a higher pressure, okay, let us see what we are getting. So it will become like this. So you are doing this for a higher pressure, so you will get a curve like this, because at higher pressure, that means the water boils at higher, so not water, for any substance will undergo the phase change process at a higher temperature. So that means when saturation pressure increases, saturation temperature also increases. Okay, so you can draw this for many lines. So it will be, here it is 1 2 dash 3 dash 4 dash 4 5 dash 6 dash. ലീനു സൗണ്ട് കുറച്ചേ. 2 double dash 3 double dash 4 double dash and then 5 double dash 6 double dash. So if you draw the locus of all these saturation points, you will get like this. So that is, so if you connect this, you will get okay. So this is how you will get the TS diagram. So this is for different pressures. So this one is for P1, this is for P2, and this is for P3, and like that. So for now, if it is above the critical pressure, the phase change occurs just like that. That means there will not be a significant entropy change from these saturated liquid to saturated vapor. Right, now let us see why this 4 dash is tilted towards the right of 4. Okay, that means you know that P4 dash is greater than P4. So that means T4 dash also will be greater than T4. So what happens to the entropy S4 dash? If you compare that with the S4, it will be greater than S4 because temperature will cause the entropy to increase. Okay, because higher the temperature, more will be the entropy. But if you increase the pressure, it will try to bring down the entropy because it will try to bring the molecules closer together. It will reduce the disorder. So it will be it will reduce the entropy change. Entropy. So that means, but the influence of pressure is low compared to temperature for a liquid. Okay, so this has got a bigger impact. That is why S4 dash is greater than S4, right? But if you look here, you can see that S5 dash is less than S5. Okay, why is it so? It is because you can see that the pressure P5 dash is greater than P5, and also T5 dash is greater than T5. And we have seen that this temperature causes the entropy to rise and the pressure causes entropy to decrease. Okay, entropy will decrease, but now it has become a gas, so the effect of pressure on gas is significant compared to the temperature. So that is why S5 dash is less than S5, because the impact of pressure is higher compared to the temperature. So this is the difference. So this is all about the TS diagram of a pure substance.